Hey, Mr. Crowley here for Earth Science. Hey, I'm right now I'm walking into what is called Pine Creek, which is a tributary of Mill River. Remember, a tributary is a smaller river flowing into a larger river. So anything that runs off the surface of the earth here will end up down in Mill River and out in the bay, which is very important, okay? So we are in a drainage region. I guess we could call it the Mill River drainage region. And what do I mean by that? Well, when water, I'm gonna spill some water on the ground here. When water falls on the ground, you might be able to see, maybe I'll do it this way, let's see. You should notice the water flows from high to low. Some going over in this direction, some heading over in this direction. So we could think of this being the Mill River drainage area. So if you notice, there's not much water flowing through here right now. We would say that it has a very low discharge. But if it rains later, I would expect to see this fill up quite a bit. And we would expect that the discharge would increase. And that means a greater volume of water, right? And the levels would rise, and its carrying capacity should increase. It should be able to definitely pick up some of these particles of sand, silt, and clay. Impressions there. And some of these larger pebbles might actually roll along the bottom. All right, so here I am. I'm back in the channel here. Not too much water. And you should notice there are a few things. We generally say rivers make V channels, small V channels. So the shape of the channel should be a V. We're going to see that glaciers, another agent of erosion, produces very large U-shaped channels. Rivers are also very good at rounding the rock fragments. If you look, most of these pebbles in here are pretty rounded, all right, compared to some of the other agents like landslides, or I should say just gravity in general, glaciers. The particles tend to be more angular. They're also generally tend to be, when they get deposited, well sorted. And that has something to do with page 6 of the reference table that you've been learning about. When the river slows down, it starts dropping out the biggest particles first. So it's probably hard to see, but the river here, the creek, whatever you want to call it, is moving. Its ability to carry particles, remember, would be dependent on its velocity, how much water's in there and how fast it's moving. So let me just throw some sediment in there, and not much is moving. I'm not sure if you can see that the water's moving here. It's moving very slowly, so it's really not carrying much. I'm going to throw a mix of sand, silt, and clay and some pebbles in there, and let's see what happens. Sure enough, you can see some of the finer particles moving there. Okay, so I'm not sure if you can see this, but I put a marker here in the ground and a marker over here in the ground. That represents a distance of 1 meter. We could actually calculate the velocity of this stream if I just put a piece of paper in, and we can time how long it takes to go from one point to the other. Remember, we can say, 1 meter is 100 centimeters, which would be a unit used in the reference table on page 6. I'm going to drop this piece of paper in. Let's watch it flow down. We'll start the stopwatch as soon as it crosses this marker here. Here we go. And start. And stop. Oh, I need to stop this.